This is a revision video of properties of electromagnetic waves. Different objects, different substances can interact with waves in different ways, and this can depend on wavelength. So for example, if we have a red t-shirt, that will absorb all colours of light. It will absorb all colours of light apart from red. It will reflect red, so it sees and it looks to us red. And the reason this is the case is because the wavelength of 650 nanometers is reflected. All other wavelengths are absorbed, so it varies with wavelength. Only higher tier students need to know that it depends on wavelength. We've got another phenomenon called refraction. And refraction is where waves speed up or slow down, and because they speed up or slow down, they change direction. So let's think about light going through the air into a glass block. So here I've drawn a glass block. I'm going to draw a normal. And so let's say we have the incident ray, that means the ray coming in, the ray of light coming in, that's the incident. What happens when that incident ray goes through the glass block? It slows down. And because it slows down, it changes direction towards the normal. Instead of it just going straight through, it changes direction towards the normal. So it changes direction. And that change of direction is called refraction. And as it leaves the glass block, I've drawn another normal, it speeds back up because it's going into air. So when it leaves the glass block, it goes away from the normal, so it's refraction again. So what refraction is a wave speeding up or slowing down, therefore it changes direction. Anytime a wave changes direction, it's because it's changing speed. So this is called a ray diagram of refraction. We can also show refraction in terms of a wave front. So let's say we've got shallow water here and we've got deep water here, and I've put it on an angle for a reason. So shallow water, the waves are all going towards the deep. But as it gets to the deep water, it slows down. So we draw a normal. So the waves are going in that direction. And we draw our normal. And it's going to change direction towards the normal. So the average wave is going to go in that direction. It's going to change direction because it's going to slow down in deep water. And what happens, because this part of the wave hits first, that changes direction. So what happens is the wave front has changed direction because the speed of the wave has slowed down. Slow in the deep water, fast in the shallow water. Key thing is, changes direction because the speed has changed. It's also important to notice when it slows down, the wavelength gets shorter. So we can show this more specifically. So we've got deep on this side, shallow over here, and I'm going to exaggerate the wavelengths. So long wavelength in shallow water, in deep, could it slow down, the wavelength gets closer together. Could it slow down? The key thing is all about the change in speed of the wave.